in. This is this V in. Now, during the positive half cycle, can you tell me which are the diodes that will come into operation? So during the positive half cycle, if this is the polarities of the voltage source, then the current will try to go through your diode D1, and then it will go through the load like this, and then while coming back, they will try to go through D2 and come back to the circuit like this. But there is a problem here, is that you have a voltage source. So suppose the voltage source magnitude is like this, E. So as long as you don't reach that point, will the diode D1 and D2 will be in forward biased?
No, sir.
So until unless we reach to that point when suppose this angle is my alpha. So as long as my, suppose this is Vm sine omega t, that is the equation of the waveform. So what should be this magnitude? Then it should be Vm sine, instead of using omega t, we can say this is my alpha. So Vm sine alpha, that should be equals to E. As soon as it reaches this condition, then what will happen? D1 and D2, it will be in forward biased. Right? So what will happen to the output current then? Output voltage then? So before this point, what will happen to your output voltage? V naught. Since there is no current here, so there will be no drop across the resistor. So your output voltage would be equal to your battery voltage, right?
Yes, sir.
Is there any confusion regarding this? Anyone? So before this point, your output voltage will be equal to your battery voltage E. And then as soon as your input voltage becomes higher, then your battery voltage, then diode D1 and D2, it will be operating. And as soon as D1 and D2 is operating, this path will look like short circuit. So D1 and D2 will be short circuited. Then your entire voltage, this positive terminal will come here. And negative potential, it will come here. So the entire input voltage will appear across the output. So from this point to this point, your output will be similar to your input voltage. Is there any confusion regarding this so far?
No, sir.
Then again, for this part of the signal, since there is a negative potential, so the polarities of the input signal will change. So now it will be negative. This terminal will be positive. So the current will try to go through this path, and it will go through D3 like this. Then it will go through the load like this. And while coming back, what they will do, they will try to go through like this, and in that way it will come back, right? So now then, if I want to draw the waveform there, so similar to what is happening here, D1 and D2, So at this point, D1 and D2, it is operating.
Because sir, finally.
Any question?
আমাকে জিজ্ঞেস করতেছিল আমাকে 317527
Anyone? Is there any question?
731
So again,
কয় টাকা আছে সেটা দেখো, অনেক সময় টাকা দিয়ে দেয় তো।
from here to here, again, since the battery is there, so the diode D3 and D4, it will not get the forward biased condition. But as soon as for the negative half also, this magnitude becomes equal to your voltage source, then again, your D3 and D4, it will start operating, and then your entire input voltage will appear across the output. So your waveform will be like this, and during this point, your D3 and D4, it will be operating. Any confusion regarding this? So here, if you want to draw the input, if you want to get the output current here, that is your I naught. So how the I naught will look like? So before the diode D1 and D2 is forward biased, what will happen to the current? The current will be 0 up to this point. And then after that, when this diode D1 and D2 is operating, your current will have the similar wave shape like the voltage, input voltage, but this magnitude will be divided. The maximum value of this should be Vm over R. So not this is Vm, it should be your current magnitude, it should be the maximum value of it, Vm minus E, that is the maximum value of the source voltage. So Vm minus E divided by R, that should be the maximum point magnitude. And then after that, from here to here, it would be again 0. And then during the negative half cycle, this up to this point, up to this point, the current will be again 0. And then when D3 and D4 starts operating, the current will have the same waveform like the input signal. And again, its magnitude would be Vm minus E over R. And then again, it would be 0. So that is the current here. So if I want to get the input current, then I input. Can anybody tell me how the input current will look like? Anyone? Suppose this is omega t. So during that time, before this portion and this portion, the current is 0. But after that, since the current direction is given by the black line here, so current will have the positive current direction like this. So this is that portion. And the maximum value of this current, it would be Vm minus E over R if I'm doing that for input current. So now, what during the negative half cycle, should the current on the input side, is it changing or it is remaining the same as the output current?
So changing.
Changing. So in that case, from this point to this point and here, the current would be 0, but here the current waveform will be the similar, but it will flip for the input current waveform. So is there any question regarding this so far what we have discussed for simple resistive load with a battery source.
ইনপুট কারেন্টটা কেন 0 থেকে স্টার্ট হয়নি?
Sorry, I didn't get you.
স্যার ইনপুট কারেন্টটা কেন 0 থেকে স্টার্ট হয়নি?
Input current is changing because during the positive half, when the polarities is like this, the input current is going in that direction, like this. So through D2, it is coming back here, but during the negative half cycle, the polarities of the source will be different, as we have shown in with the red line. So current will go in the opposite direction through D3, and while coming back, it will come through D4 and go like this. So the current direction is changing. That's why we are saying it is positive and negative. So if I say this is my alpha, where this current will start going through the circuit, and this angle is my beta angle. From here to here, this is my beta angle. So what should be the current equations? My I naught, it would be Vm sine omega t minus E over R, where your angle is alpha greater than or equals to omega t greater than or equals to beta. Any question regarding this so far? Anyone? So now in our previous case, we are thinking about somebody asked me why it is not starting from 0. What was your question? Can anybody that is not we are discussing here. That the waveform that you have shown there, that is for the inductive circuit. But we are dealing with here with the resistive circuit. So resistance doesn't have the capability to store the current or energy. It can only consume the energy. So that's why the portion that you are showing in the comment box, it will not happen exactly the same way that we have for the inductive circuit. So now when you have a full wave rectifier circuit with highly inductive load, so let me draw the full wave rectifier circuit again. So suppose this is my full wave rectifier circuit, and we have a 4 diode. So suppose this is connected here, and here we have another portion. So this is my D1, this is D2, this is D3, this is D4, and now it is connected with a highly inductive load with a battery source. Suppose this is my output V naught. So now can anybody tell me what will happen here? Sorry? I didn't get you. Can you repeat your question?
The change won't be abrupt like before.
I'm listening to your voice with very low voice, so I cannot hear what you're trying to say.
Sir, output current will be constant.
Yeah, right. So for highly inductive load, I have already discussed with the equation derivation. I think the derivation is well explained in your class lecture, so I'll not go through that. Do I need to go there? Suppose we have a sinusoidal waveform. This is my input voltage V in, and we have a purely sinusoidal wave like this. So now, since there is an inductive load here, so the inductive, due to high inductive load, the current through the inductor, it will be always a constant current. So whenever you have a constant current, so what will happen? Either they will come from D1 and D2 or D3 and D4, because you are not putting a flywheel diode here. So what will happen? Whenever the current needs a path, it will take either D1 and D2 or D3 and D4. Unlike the condition for resistive load, because resistance for resistive load, its current will depend on the voltage. So when there is a voltage, then there will be a current through this resistor. But for inductive load, it can store energy. And if the inductance value is high, then the inductance here will make sure that the current through it becomes continuous. So what will happen then? If I want to get the output voltage here, omega t, V naught. So what will happen here? My output voltage will be exact replica of input voltage, but then for the negative portion, it will be just flipped. And here, for this portion, D1 and D2, it will be operating. And during the negative half cycle, my D3 and D4, it will be operating. So one might ask me, sir, why we are not considering a battery source here? Because for the previous cases, when you have the resistive load, the current was not continuous. As you can see here, the current is not continuous because the resistance, it cannot store the energy. So the current can only flow through this whenever your input voltage or the voltage that is appearing here, A and B, it is higher than your source voltage. But in this case, the inductor is forcing either D1 and D2 to be turned on or D3 and D4 to be turned on, as the inductance value is very high. So whenever your VAB point here, suppose this is my A point and this is my B point. So the polarities across it, since D1 and D2 is operating, so whenever the polarities is like this, the current needs a path. So D1 and D2 will be forced to remain turned on by the inductor. So during that portion, these polarities will appear across the load like this. Since D1 and D2 is operating, it will look like a short circuit. And during the negative half cycle, although the polarities is changing, but the inductor current will be unidirectional because the inductor doesn't like the current to change its direction or change its magnitude. So what will happen? The inductor will force this D3 and D4 to turn on so that current can go through D3 like this and while returning back, it can come through D4 like this. And if you want to see the output current there, then the output current here, it would be my omega t. And if I want to show you the output current, suppose this is my output current. So your output current will be a constant value. That is my I naught. Suppose this is my I naught. Now, what would be your input current then? Your input current, anybody is asking me any question? So in that case, while D1 and D2 is turned on, then current will go through D1 in a certain direction. And while D3 and D4 is operating, the current will go changes direction. But across the load, the current direction would be in directional. So in that case, if I write it down I in, my current here would be similar to this one. But during the negative half cycle, for the input current, it will change its direction like this. Is there any question regarding this so far? Can you realize what is happening here because of the inductive load, highly inductive load? Any question regarding this? Anyone? You are understanding or not understanding anything that I have said so far?
Yes, sir, we understood.
Now, if you have a current like this, that is DC for a certain period and it reverses its direction, but still it is DC, that thing is problematic because if you do a Fourier analysis of this waveform, you will find that there is a lots of higher frequency harmonics present here. Higher frequency harmonics. So what is the detrimental effect of a harmonics? Can anybody tell me?
Sir, core loss will increase.
So core loss, it actually depends on voltage and frequency. So if you see there are lots of harmonics that are being introduced by the highly inductive load, then you will find that the core loss is increasing, and this input power, it is actually coming through some kind of transformer. So if the frequency content is higher, the transformer will feel more losses and it will get warm or it will get heated. So that might reduce the total operational lifespan for the transformer. So if I want to do the analysis of this waveform, this current waveform, do I need to go to that math that we have done, or you have understood how the math were been done in the class? Do I need to repeat that math problem here?
ম্যাথটা রিপিট করলে ভালো হয়।
Do I need to repeat it?
স্যার রিপিট করলে ভালো হয় স্যার।
Okay. So as you can see from the Fourier analysis, It is said that any signal, whether it is current or voltage, it can be represented as a DC component of current, that is IDC, and it will have some higher frequency components like n equals to 1 to infinity, then an cos n omega t plus again n equals to 1 to infinity bn sine omega t. So what does it means? Suppose you have a flat waveform like this. So suppose we have a sinusoidal signal of fundamental frequency, and then if we add with it a third order frequency signal, that is third harmonics, you will find that your waveform will be like this. So again, if you add with it a fifth order circuit, fifth order sinusoidal circuit, the more higher frequency you add with the fundamental frequency signal and you add them up, you will find that this thing, although it has some ripples in it, it will be flattened after combining all the high frequency components of the sinusoidal signal. So that's what the Fourier analysis says. When you have a DC component, as well as you add up all the high frequency sinusoidal signal, you will get a non-sinusoidal signal, or vice versa. Any non-sinusoidal signal can be represented as a series of sinusoidal signal with a DC component with it. Do you understand what I am trying to say?
Yes,
Any
sir.
regarding this? Okay. So now, if I want to do the, suppose now we are dealing with this signal. So if I want to do the DC current component of this signal, DC means what should be the DC value? It should be 1 over 2 pi from here to here, and then it should be 0 to 2 pi I in we can say d omega t, I in omega t multiplied by d of omega t. So since this signal is a flat one, so we can write it down as 1 over 2 pi. Then from 0 to pi, the value, it would be what? Suppose this is my positive I naught, and this value, this is my negative I naught. So 0 to pi, it should be I naught multiplied by d of omega t. And during the from pi to 2 pi, it would be minus I naught, then d omega t. So what should be the average value then? It should be 0, right?
Yes, sir.
So when any signal is symmetric about the reference axis, we can say the DC value of it should be 0, right? That is also true for any sinusoidal waveform or the triangular waveform. If you have a sinusoidal waveform that is symmetrical about the reference, or a triangular waveform that is symmetrical about the reference, you can always say that the average value or the DC value of this signal, it should be 0. So now what is the coefficient of an and bn value then? So if I want to write it down, my an and bn, so the equation for an is 1 over pi, that is 0 to 2 pi. Then what is my current? It should be I in multiplied by cos n omega t multiplied by d of omega t. So now, as we did here, 1 over pi from 0 to pi, what is the value of I in? I in is I naught, right? And then it should be cos n omega t multiplied by d of omega t. And for pi to 2 pi, what is the value of I naught? Sorry, I in, it is minus I naught, right? So it should be I naught cos n omega t multiplied by d of omega t. So now if you do the integration, what should be the integration? Again, so let me bring out I naught here. So we can write it down as I naught over pi. Then it should be 0 to pi cos n omega t multiplied by d of omega t minus, since you have a minus here, so minus, it should be pi to 2 pi cos n omega t multiplied by d of omega t. So it should be I naught over pi. Then what is the integration of cos n omega t?
Sir, sin n omega t by n divided by n.
Over n sin n omega t, and the limit should be pi to 0 minus, it should be again 1 over n sin n omega t, and it should be pi to twice pi. So what is the value of sin pi? It should be 0. What is the value of for sin 0? That is also 0. So this whole term, it would be 0. Again, what is the value of 2 pi? Sin 2 pi, it is 0. You are understanding what I'm trying to say, right? This is 0, this is pi, this is 2 pi. So whenever you have a multiple component of pi, the sine waveform value is what? 0, right? So this term will be also 0. So finally we can say my n, it would be equals to 0. Is there any confusion so far? Anyone?
No confusion.
Okay. So now if I want to do the calculation for Bn, what would be my Bn? It should be 1 over pi. Then it should be again summation 0 to 2 pi I in multiplied by sine n omega t d of omega t. So again, it should be 1 over pi. Then we can write it down as 0 to pi I naught sine n omega t d of omega t plus pi to 2 pi minus I naught sine n omega t multiplied by d of omega t. So it would be 1 over pi. Then if I take I naught out, so it would be I naught over pi. And then what should be the integration of sine wave? Minus 1 over n cos n omega t. And the limit should be pi to 0. And here you have minus, and integration of sine is minus cos. So minus minus, it will become plus. So again, it would be plus 1 over n cos n omega t, and it should be twice pi to pi. So if I take this 1 over n out, so it would be I naught over n pi, and then here I should have cos twice pi n minus cos pi n, and then I have minus here, so minus, then I can write cos pi n minus cos 0 degree. So now tell me, I naught over n pi, what is the value of cos twice pi n? Cos waveform, it will look like this, right? So at 0, the value is 1. When you have pi by 2, the value becomes 0 again. When it is pi, the value is negative. Then when you have 2 pi, then what will happen? The value is again positive, right? So whenever you have this value 2 pi n, this value becomes 1, right? When you have a value here pi, this value becomes minus 1, and you have minus at the front here. So minus minus, it becomes plus, and this value, it is also becoming minus 1, and this value, it is becoming 1. Did I make any mistake here? So here 1 plus 1, it becomes 2, and here minus 1, and here we have minus 1, and we have minus at the front. So 2 plus 2, it becomes 4 I naught over n pi. Any question? So what would be my I in then? My I in was IDC plus summation n equals to 1 to infinity. Oh, okay. One thing I forgot to uh, tell you is that this n value, it can be either odd or even, right? Odd or even. So if this is my n value is odd, like 1, 3, then what will happen here? This value will become 1, this value become minus 1, this value becomes minus 1, this value becomes 1. But when your n is even, so n is even means 2 pi position, so it would be positive. This will be also positive. So positive value minus positive value, it will become 0. Again, when your n is even, so it would be something like 2 pi. And again, cos 2 pi is plus 1 and cos 0 is 1. So this term will cancel out. So this thing that we have got here, Vn, it is only true when your n is odd, meaning it is 1, 3, 5, 7, 9, so on. And this value will become 0 when n is even number, meaning 2, 4, 6, 8, 10, and so on. So now if I want to have the actual input current equation, then it would be an cos n omega t plus summation n equals to 1 to infinity bn sine n omega t. So now we got this DC value is 0. This an value is also 0. So actually my equation for input current, it would be I in, it would be my Bn sine n omega t when n is 1, 3, 5, 7, 9, and so on. Any question regarding this? So now, if this is your equation, then how we can write it down? So now we can write it down like, if I put this value here, so my I in, it would be 4 I naught over n pi sine n omega t when n is equals to 1, 3, 5, 7, and 9. So if I elaborate this equation, we can write I in equals to 4 pi, 4 I naught over pi. If I write it down here, so 4 I naught over pi, that is my constant term. When n value is 1, we can write it like sine omega t plus 1/3 sine price omega t plus 1/5 sine 5 omega t, 1/7 sine 7 omega t, and so on and so forth. Any question regarding this? So what should be the my RMS value then? My RMS value, it should be what? If you have a current I that has so many components, that is my fundamental components, then third harmonics component, then fifth harmonics component, and so on and so forth, then the RMS value of this current, it would be square root of RMS value of the fundamental component, then RMS value of the third harmonics component, then RMS value of the fifth harmonics component, and so on and so forth. So by do this, can you tell me from a sinusoidal waveform how you can get the RMS value? Anyone? From a simple sinusoidal waveform, how you can get the RMS value?
Sir, root over 4 I naught by pi.
So suppose we consider this A. So actually my equation would be A sine omega t. Then it would be A by 3 sine 3 omega t plus A by 5 sine 5 omega t, so on and so forth. So this is my magnitude for the sinusoidal waveform fundamental frequency. This is the magnitude for third harmonics frequency. This is the magnitude of fifth harmonics signal. So if I want to get the RMS value, then what would be the RMS value? What is the RMS value of the fundamental signal RMS value? It should be A over √2, right? And then we have to take the square of it like this. What is the RMS value of the third harmonics component? It would be A by 3, that is the amplitude, and then we have to divide it by 2, and then square, do the square of this. That should be my RMS value of the third harmonics component. What would be the RMS value of the fifth harmonics component? It should be A over 5√2 square, and so on and so forth. So if I take A by √2 out of the equation, so it would be A over √2. If I take it out, then what would be my equation then? It would be 1 plus 1 over 3 whole square plus 1 over 5 whole square, and so on and so forth. So this term, we can write it down A square root of summation p equals to 1 to infinity. That is my, and then we can write it down as 1 over 2p minus 1 whole square. So if you put the value of 1, so 2 minus 1, it would be 1 over 1 square. So it should be 1. And then if you put p equals to 2, 2 multiplied by 2, it would be 4 minus 1. So 1 over 3 whole square. That is this. If you put p equals to 3, so 2 multiplied by 3, 6 minus 1, that would be 5. So 1 over 5 square, and so on and so forth. So by doing this term, we can get the value. If you have a series like this, then I think you have learned that in your calculus class, that the integration of this thing, if you take that as series, then you will get this value as square root of pi square over 8. So 8, if you take square root of that, so it would be A over √2, and then it would be pi over 2√2. So then your I in RMS value would be what? Pi A over what? Pi A over 4, right? So now,
Yes.
if I put the value of A, we can write pi over 4 multiplied by 4 I naught over pi. So this pi and pi will cancel out. Four and four will cancel out. So it would be I naught. Understand? No. No. So now this is the RMS value of the input current. So now if you want to do the harmonic factor, what is the definition of harmonic factor? That is the input current RMS value over input current first harmonics value square minus 1. So what is the input current RMS value? That is my I naught. And what is the first harmonics RMS value? A over root 2. So what is A over root 2? If I say this is IS1, so I in 1, like we did here. So what is the RMS value then? A over root 2. So what is my A? A is 4I naught over pi and then root 2. So can anybody calculate what is the value of this one?
Can you repeat the question?
Can you calculate what is the value of this one? Zero 0.90 I naught, right? So if you put that 0.90 I naught whole square minus 1, so this I naught will cancel out. So what 1 by 0.0 whole square minus 1. So what should be the value? Zero 0.48, meaning the harmonic component is 48%. Now, what should be your displacement factor? Displacement factor is the cos phi. So what is phi? Phi is the displacement. So if you see here, what was my waveform? This thing. So this is my waveform of current input, and this is the waveform of input voltage. So if I take the fundamental component of current for this waveform, it will appear like this. So if this is my I in 1, the fundamental component of the current. So what is the displacement of fundamental component of the current with respect to the input voltage? They will be in phase or out of phase. If this is the fundamental component of the current, so you compare this waveform with the input voltage. So these two waveform, whether they will be in phase or out of phase?
Phase.
Phase. So if
In
they are
phase, sir.
phase, they are in phase for voltage and current, then what should be the displacement factor? It should be cos 0 degree. That should be equals to 1. And then what should be your input power factor? PF. That should be also equals to, we have known now, it should be I in 1 over I in multiplied by displacement factor. So what is your I in 1? We have just calculated that 0.90 I naught over what is I in
I not.
I naught. I naught. And what is your displacement factor?
1.
So what should be the input power factor then? 0.90, and it should be lagging. Why it should be lagging? Because you have a inductive load here, right? So let's do one thing. How about I close my class here today and I will take another session tomorrow at your convenient time to cover up the rest of the lecture so that you can go through today's lecture. And if you have any question, you can ask me tomorrow. And we after that we can cover the remaining part of the syllabus for the next quiz. Or should I continue it today?
No, sir.
Anybody tell me what should I do? Should I
So we can try to go through it and then we continue later.
where can you do another class tomorrow? Page number of today's topic, it is already given you your lecture sheet. So just go there and see all the references with their page numbers are mentioned in the class lecture. And the remaining topic, as I said, there are 4 topics, 4 lectures, in total 2 weeks lecture there. So I think we have done more than half of it, because you have an online course, online lectures before with the syllabus what we have discussed today. So almost I can say 70% syllabus is covered. So the remaining 30% we can discuss it tomorrow. So Fawad or Istiak or others here, are you present here?
Yes, sir.
So when we
Sir,
can
tomorrow same time will be tomorrow same time is okay.
when that
Sir,
time?
8 p.m.
8 p.m.
Yes, sir.
How about from 6?
Sir, from 6. Sir, নামাজ আছে তো সময়।
Okay,
স্যার
6:30 to 8.
আফটার 7 হলে ভালো হয়।
7.
জি স্যার। স্যার 7:30 থেকে 7:30।
Okay, how about then 8:30? I have some work from 8 to 8:30. So how about from 8:30 we will take another hour, 8:30 to 9:30.
ওকে স্যার।
Okay, now then we end our class here and just go through the topic that I have discussed today. And if you have any question, then you can ask me tomorrow. Otherwise, we'll be covering new topics tomorrow.
স্যার আমাদের এই ক্লাসের রেকর্ডটা ড্রাইভ লিংকে আপলোড করে দিলে ভালো হয়।
I will do that within 5 minutes, inshallah.
স্যার আমাদের কুইজের কোশ্চেন কিরকম আসবে? ম্যাথমেটিক্যাল কোশ্চেন?
Most probably, I will give you one very small theory question. Like I might give you one situation on how the output will look like, something that we have done today. or similar to the circuit what we'll be discussing tomorrow. And then I will give you one math problem, and you will be asked to find the values of something like that, the frequency components, which are the components that will be present, and similar to what the math we have done today. Okay. So basically, it will have two questions. One is the math question, and another is the theory question.
জি স্যার।
Any other question?
স্যার ম্যাথটা কি স্যার আজকের টপিকস থেকে আসবে? মানে আজকে এই টপিকস স্যার ম্যাথের একটা পার্ট ছিল।
আরো স্পেসিফিক জিজ্ঞাসা করো স্যার, কত নম্বর কোশ্চেনটা আসবে?
স্যার ওটা বলে দেন ভালো হয়।
হ্যাঁ, ঠিক আছে। আমার বিকাশ নাম্বার জানো তো নাকি?
Assalamu alaikum, sir.
ওয়ালাইকুম আসসালাম।
Sir, according to the updates we received from the CR and what you are saying, we don't understand with regards to the syllabus. Do you mean the syllabus for the quiz covers up to today and tomorrow's class?
Actually, what I said before is that I have sent the CRs for class lectures. Okay. So the syllabus for the quiz will be those for class lectures. But for the first one or two class lectures, I have done one online class before, so you can see the syllabus content there in the online class video. Okay, so that thing I didn't cover it today. I didn't